Hello friends, do you know about Spintronics? Let's talk about it. Spintronics, short for spin electronics. This is a field of physics and electronics that focuses on utilizing the intrinsic spin of electrons, in addition to their charge, to develop new electronic devices and technologies. Before the advent of spintronics, the field of electronics primarily focused on the manipulation of electron charge for information storage and processing. This is what we called conventional electronics. This relies on the movement of charge carriers, electrons or holes, and has been instrumental in the development of various technologies, such as integrated circuits, transistors, and memory devices. However, they have certain limitations in terms of power consumption, speed, and data storage density. In the pre-spintronics era, several key technologies and concepts paved the way for the development of spin-based electronics. 1. Quantum mechanics, the mechanics for the microscopic particles. The field of quantum mechanics, which emerged in the early 20th century, provided the theoretical framework for understanding the behavior of electrons and their intrinsic properties, including spin. Quantum mechanics laid the foundation for spintronics by revealing the potential of utilizing electron spin as an additional degree of freedom for information processing. 2. Semiconductor materials, the basic backbone of electronic devices. Silicon became the dominant material for manufacturing electronic devices due to its desirable properties, such as its abundance, stability, and compatibility with the fabrication processes. Other semiconductor materials, such as gallium arsenide, GaAs, also found applications in specialized electronic devices. 3. Transistors are fundamental electronic devices that amplify or switch electronic signals. The invention of the first transistor in 1947 by John Bardeen, Walter Brattain, and William Shockley at Bell Laboratories revolutionized electronics. Transistors made it possible to miniaturize electronic circuits and enabled the development of smaller, faster, and more powerful electronic devices. Next, number 4 is integrated circuits, IC. Integrated circuits, or microchips, brought together multiple transistors, resistors, and capacitors onto a single semiconductor substrate. The development of integrated circuits in 1950, early 60s by researchers like Jack Kilby and Robert Noyce led to a significant increase in computing power and paved the way for the modern digital. Number 5 is magnetic storage. Magnetic storage technologies, such as magnetic tapes and magnetic hard disk drives, HDDs, played a crucial role in data storage. HDDs, in particular, relied on magnetic read and write heads to store and retrieve data magnetically on spinning disks. 6. Is magnetoresistance, giant magnetoresistance, GMR, and tunnel magnetoresistance, TMR. Magnetoresistance is the tendency of a material to change the value of its electrical resistance in an externally applied magnetic field. The discovery of magnetoresistance phenomena, including GMR and TMR, in the late 1980s and early 90s paved the way for advancements in magnetic storage and magnetic sensors. These effects involve changes in electrical resistance depending on the relative orientation of magnetic layers, allowing for high-density data storage and sensitive magnetic field detection. It is important to note that spintronics as a distinct field of research emerged in the late 20th century, with notable contributions from many researchers. Albert Ferd and Peter Grunberg, who independently discovered the phenomenon of GMR in 1988. This discovery opened up new possibilities for utilizing spin in electronic devices, leading to the birth of spintronics as a field. This subsequent exploration of its applications in information technology, computing, and beyond. In traditional electronics, the charge of an electron is primarily utilized to carry and process information. However, in spintronics, both the charge and spin properties of electrons are harnessed, leading to potential advancements in various electronic devices. The fundamental concept of spintronics relies on the quantum mechanical property of an electron called spin. Quantum spin can be thought of as the intrinsic angular momentum of an electron. It can have two orientations, up and down, represented as binary values of 0 and 1, or as spin-up and spin-down states. One of the key goals of spintronics is to create electronic devices that utilize spin rather than or in addition to charge. The working principle of spintronics involves several key phenomena and components. First is spin generation. Spin can be generated in various ways, such as through the injection of spin-polarized electrons from a ferromagnetic material or by using the application of an external magnetic field. Techniques like spin injection, spin pumping, and spin Hall effect are employed to create a spin-polarized electron population. Next is spin transport. Once spin is generated, it can be transported through materials, such as metals, semiconductors, or insulators. Spin transport is influenced by factors such as spin scattering, spin relaxation, and spin orbit interactions within the material. Materials with long spin lifetimes and minimal spin relaxation are desirable for efficient spin transport. Then comes spin manipulation. Spin manipulation involves controlling and modifying the spin orientation of electrons. Various methods can be used to manipulate spin, including external magnetic fields, spin orbit interactions, and spin currents. Spin manipulation techniques are crucial for encoding, processing, and detecting spin information. Final step is spin detection. Spin detection involves measuring the spin orientation of electrons to extract useful information. This is typically achieved through spin-dependent phenomena, such as magnetoresistance, where the electrical resistance of a material depends on the relative alignment of the spin orientations. Techniques like GMR, giant magnetoresistance, and TMR, tunnel magnetoresistance, are used for spin detection in spintronic devices. By manipulating and detecting the spin state of electrons, scientists aim to develop more efficient, faster, and lower power consuming devices. Some potential applications of spintronics include 1. Spin-based memory devices. Spintronics enables the development of non-volatile memory, such as magnetoresistive random access memory, RAM. RAM utilizes the magnetic orientation of electron spins to store data, providing fast read and write operations, high data retention, and low power consumption. 2. Spin-based logic devices. Spintronic devices can be used for logic operations, enabling the creation of spin-based transistors and spin-based logic gates. These devices have the potential to overcome certain limitations of traditional semiconductor-based transistors, such as power dissipation and leakage currents. 3. Spin-based sensors. Spintronics can be employed in various sensor applications. An example is giant magnetoresistance (GMR) effect. Magnetic field sensors based on the GMR effect, which relies on the spin-dependent conductivity of certain materials, are used in hard disk drives and magnetic field detection. 4. Spin-based quantum computing. Spin qubits, which encode quantum information in the spin states of electrons, are a potential candidate for quantum computing. Spin-based quantum bits offer advantages such as long coherence times and compatibility with existing semiconductor fabrication techniques. 6. Spin-based communication. Spintronics can enable novel methods for transmitting and processing information. Spin currents can be used to carry information over short and long distances, potentially leading to new communication technologies with higher bandwidth and lower power consumption. 7. Energy harvesting. Spintronics has the potential to contribute to energy harvesting technologies. Spintronic devices can convert waste heat into usable energy by utilizing the Seebeck effect and spin-dependent thermoelectric effects. 8. Spin-based imaging. Spintronics can be utilized in advanced imaging techniques such as magnetic resonance imaging, MRI, and magnetic resonance microscopy. By manipulating the spins of atoms or electrons, more detailed and sensitive imaging can be achieved. Spintronics is an active area of research and development, with ongoing efforts to explore new materials, improve device performance, and expand its application potential. It holds promise for advancing the capabilities of electronic devices and contributing to the development of future technologies. Thanks for watching. Follow for more informative videos.